Hi Geometry, welcome to Special Right Triangles. I've been talking about these. It's that 30, 60, 90 triangle. That means 30 degrees, 60 degrees, 90-degree triangle. And 45, 45, 90-degree triangles. Okay, so you might see some of these shapes. Oh, this is kind of hard because it's clear. This is a 30, 60, 90 triangle. This angle up here is 30. Angle down here is 60, and then there's your right angle. And also in the center you have the same thing. They come in, they're famous in all those geometry kits that you may get. And I might have a couple lying around, but they're probably at school. Okay. So I can use relationships amongst the sides in special right triangles. And I can use a ratio of sides in special right triangles to solve real life problems. So a little bit of practice. Let's multiply this. This is the same as 6 times the square root of 2 squared. Well, remember what a square and a square would do? They cancel each other out. So it's just 6 times 2, which is equal to 12. Here we want to rationalize the denominator. I know in other countries it's okay to keep it like this, but in the United States we like to do that. I am multiplying both the numerator and the denominator by square root of 3. Because square root of 3 divided by square root of 3, it's a hard, tough 3 to see, is 1. So I'm taking my original problem, multiplying it by a form of 1. So on the top, you get 6 times the square root of 3. And the bottom, square root of 3 times square root of 3 is 3. Because remember, if you square a square root. And then this reduces, and I get 2 times the square root of 3. How about this one? Let's multiply the top and bottom, the numerator and denominator, by square root of 2. You're allowed to do this again because square root of 2 is a form of 1. So you can get 5 square root of 2 over 2. And that's your final answer. It would be weird to write 2.5 because 5 halves is 2.5. You don't want to usually put a decimal with this radical symbol. All right, so here's the fun stuff. 45, 45, 90 triangle. In a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as each leg. So the hypotenuse is leg times square root of 2. So right away, when you see every single time you see a 45, 45, 90 triangle, you're going to write x square root of 2 every single time. And I want you to keep in mind that basically these are isosceles right triangles. It's like cutting a square in half. Okay, if you cut a square in half, this side length is the same as that side length. That's why it's x. So let's look at these problems. Before we get started, I'm going to go ahead and write x square root of 2 on each one of these. X square root of 2. I'm going to do it every single time to drive you crazy. X square root of 2. X square root of 2. And last but not least, x square root of 2. That's the formula. So now let's look to see what we have. So here, x is equal to 3. So the other leg is also 3. And then this will be 3 square root of 2. Here the leg is 7 halves. So the other leg is also 7 halves. And this will be 7 halves square root of 2. Simple, huh? Here, x is equal to 1. The other leg is 1. And this will be 1 square root of 2, which can just be written as square root of 2. This is your famous one in trigonometry. Okay? How about here? X is equal to 2 square root of 2. So I'm going to, in place of x, I'm going to put 2 square root of 2, and then I have another square root of 2. Remember, square root of 2 times square root of 2 is square root of 4. Which is 2. We get 4. It's kind of a lot of work for that, isn't it? All right, how about this one? X equals 6 square root of 2. 6 square root of 2. 6 square root of 2 times square root of 2. Square root of 2 times square root of 2, we know is square root of 4, which is 2. 6 times 2 is 12. What do you think? Easy stuff? Okay, this is still recording. That's a good sign. Next page. Find the lengths of the legs of the triangle. Didn't I just do that? Oh, this one wanted the length of the hypotenuse. I found everything. I guess it doesn't matter. So again, same thing. I'm going to go ahead and put the formula down. X square root of 2. X square root of 2. You're going to see a little bit of math is going to get tricky here. X square root of 2. X square root of 2. And last but not least, X square root of 2. Got the idea? Okay, so now let's solve these. So the information I have right here, x squared 2 is the same as 5 squared 2. So that means x equals 5. Both legs. That's what's nice. Once I find it, I don't have to find it anymore. This one's a little trickier. 8 is equal to x times square root of 2. I need to get x by itself. So divide both sides by square root of 2. And there's your answer for each x. However, we want to rationalize those. So remember, multiply the top and bottom by square root of 2 over square root of 2. So you're going to get 8 square root of 2 over 2, and that reduces to 4 square root of 2 for each leg. All right, how about this one? 18 is equal to x times square root of 2. Divide both sides by square root of 2. So x is equal to 18 over square root of 2. We need to rationalize that. Multiply the numerator and denominator by square root of 2 over square root of 2. You get 18 square root of 2 over 2, and that reduces to 9 square root of 2. Do you see a pattern with these two? If you had just a solid whole number, half it, put the square root of 2 for the legs. If we had a solid whole number for the hypotenuse, half it, put square root of 2 for the legs. How about this? If there's nothing in front, x is 1. Nice and easy, huh? And last but not least, this is a tricky one. X square root of 2 is equal to square root of 3. I need x by itself, so I'm going to divide both sides by square root of 2. X is equal to square root of 3 over square root of 2. Rationalize your denominator. You're going to get square root of 6 over 2 for each leg. So many people are compelled to reduce this. You cannot, okay? Square root of 6 is 2 point something. It won't reduce nice. All right, so that was the 45, 45, 90. How about the 30, 60, 90? This is another one that you have to remember. Okay, so the hypotenuse is equal to 2 times the shorter leg, and the longer leg is shorter leg times square root of 3. Like, what? What I want you to remember is the short leg is x, hypotenuse 2x, longer leg x square root of 3. So think of 1, 2, 3, kind of. That might help. So a 30, 60, 90 triangle can be formed by dividing an equilateral triangle in half. Or isosceles. Not necessarily isosceles, definitely equilateral. All right, let's go to the next page and let's start practicing. Oh, I didn't change the name. Okay, Jacob has a team logo patch, and look at that string art that's coming up in the shape of an equilateral triangle. If the sides of the patch are 2.5 inches long, what is the approximate length, or sorry, height of the patch? Okay, so each side is, let's do this in black, 2.5. This is a 60-degree triangle, 60, 60, 60. So we're going to cut it in half. You should have known that was coming because that was on the last page. So if this is 2.5, this is going to be 1 1/4. So this is what I want you to remember for all your 30, 60, 90 triangle. The shorter leg is x, hypotenuse is 2x, x squared of 3. And we are looking for the height, okay? We're looking for this. Well, if this is 1.25, this is going to be 1.25 times the square root of 3. I know that's kind of weird to have a decimal with a radical, but let's go ahead and find the approximate answer. It's about 2.16, and that problem was in inches. All right, they didn't ask for this, but we know it's an equilateral triangle. If this is 2.5, we know that this is going to be 2.5 because you take x, 1.25 times 2. All right, so 30, 60, 90 triangle. I'm going to zoom out just a little bit. Oh, I'm zoomed out as much as I can. Can you see all that? I'll have to move it around. All right, so I'm going to put the formula down. Here's 30. So your shorter leg is x. Hypotenuse is 2x. X squared of 3. Okay, the 30-degree angle will be here. So this is x, 2x, x squared of 3. Here's your 30-degree angle. X, 2x, x squared of 3. Okay, let's see here. X, 2x, x squared of 3. X, 2x, x squared of 3. So I'm repeating this over and over and over. Hopefully you are too. All right, so now let's solve these. Okay, this says 2x equals 8. So that means if I divide both sides by 2, x equals 4. So this will be 4 square root of 3. So far so good? How about this one? 2x equals 17. So divide by 2. X is equal to 17 halves. So you're going to write 17. My 7s are crazy today. 17 halves times the cube root of 3. How about here? 15 is equal to x times the square root of 3. Divide both sides by square root of 3. I hate when I do my work that way. X equals 15 over square root of 3. Rationalize your denominator. So I'm going to multiply by square root of 3 over square root of 3. 15 times square root of 3 over 3. And that reduces to 5 square root of 3. So that's the value of x. Crazy. So if x is 5 square root of 3, 2 times x will be 10 square root of 3. How's it going? How about this one? Ooh, x squared root of 3 is equal to 3 square root of 3. So that means x is 3. 2 times x means 2 times 3, which is going to be 6. This is the famous one. Here x is 1. So 2 times 1 is equal to 2. Then substitute 1 in for x. You have 1 times the square root of 3. It's a little blurry. What do you think? X. 2x. X squared root of 3. Alright, last page. Hopefully this video is not too long. I was able to shorten up that other one from 24 to 17 minutes, so I'm pretty proud of that. A kite is attached to a 100-foot string, as shown in the diagram. How far above the ground is a kite when a string forms a given angle? So first, let's do the angle at 45 degrees. So you're looking pretty high. And then let's look down a little bit lower, the angle of 30 degrees. Alright, so when it's at 45 degrees, I'm going to draw my little 45 degree angle. This is 100. They want to know how far above the ground it is. So we're looking for this. Of course, these will be the same. Remember the formula. X square root of 2. So I have 100 is equal to x times the square root of 2. Divide both sides by square root of 2. X equals 100 over square root of 2. Rationalize your denominator. I get 100 square root of 2 over 2. That reduces to 50 square root of 2. Of course, that's the height, but that doesn't tell me anything. I can put it in the calculator, but I didn't bring it with me, so that's in feet. All right. So it's 50 times, square root of 2 is about 1.4. So it's going to be 50 plus, maybe it's about 70 feet. Okay. Let me know. And how about this one? Oh, I didn't really draw it well. Let's do this way. This is better because the 30's here, 60's here. I was drawing the wrong triangle. Okay, so here's my 100-foot string. We want to know how far off the ground we are. We want to use this triangle right there. All right, so the formula. X, wait, where's the red pen here is x, 2x, x square root of 3. Well, we know that 2x equals 100. Divide both sides by 2, x is equal to 50. Well, if this one's about 70, that one's about 50, it makes sense. When you're looking up higher, it's going to be higher off the ground. All right, here's our homework. There's our Common Core Standard. I want everybody to have a very nice evening. Take care.